Hello students, welcome back to chemistry online class brought to you by IOTA virtual learning platform. I am still your chemistry tutor Olabisi Olawoye, and today we are considering a topic which is mass and volume relationship. At the end of the class, you should be able to describe the relationship between mass, volume, mole, Avogadro's number, and so on. And you are expected to be able to calculate questions under this topic. So at the end of this class as well, some set of questions has been carefully selected for you that will aid your learning. So I want you to participate in the class. So back to the topic, mass and volume relationship. We really need to know, based on this chart, the relationship between mole and molar mass, mole and formula unit, mole and molar volume of gas. So, and from there, we need to know the definition of mole first. What is a mole? 1 mole of a substance is the amount containing as many elementary entities as the number of atoms in exactly 12 grams of carbon. That is, 1 mole of any substance contains or is compared to 12 grams of carbon is approximately 1 Avogadro's number, which is 6.023 times 10 raised to the power 23. It is also approximately equal to the molar mass. It is equal to the molar mass of elements. Mole is also equal to the molar volume of gases, or the volume that gases occupy, which is 22.4 dm cube or 22,400. So, describing this relationship, 1 mole of an element or a compound is its molar mass. That is, if you see 1 mole of an element, 1 mole of an element contains the molar mass of that element. If it is a compound, it contains the sum of the mass number of that compound. That is 1 mole. 1 mole of a gas also occupies a volume of 22.4 dm cube. Then, this can be converted to 22,400 by multiplying by 1,000. Then also 1 mole of any substance contains 1 Avogadro's number, which is 6.023 multiplied by 10 raised to the power 23. But all we are after is to be able to compare or work with mole and Avogadro's number, mole and mass, mole and volume, or even mass and volume. Any of these can be used in your calculation. So a set of questions has been carefully selected and prepared for you. I'm going to pause this video now for you to solve these questions. This is the first question, WAEC 1991. We have another one here. I will pause the video now for you to solve this set of questions. This is the third one. So after which I will come back for the solution of such questions, of those questions. So please pay full attention to the solution at the end of this, towards the end of this class, as I'm going to be solving the questions for you. So welcome back to the revision class, WAEC revision class on mass and volume relationship. The first question here is, what is the amount in mole of sodium triacarbonate 4 in 5.3 grams of the compound? Now, the major things you need to look at are the relationship between the elements. Now, what we need here is sodium, and sodium triacarbonate 4 is the only element they are referring, the only compound they are referring to here. And we also need mole and mass, because this 5.3 gram is in form of mass. So when you are given a question, identify what you are working on first before you start your calculation. So we are working with mole and mass, because the question is, what is the amount in mole of the sodium triazocarbonate in 5.3 gram of the compound? That is, if you have 5.3 gram of a compound, what will be the amount in mole? Now, from the point I've taught you earlier on, I said that 1 mole of a compound, this compound now, 1 mole of it is its molar mass. And molar mass is expressed in gram. Now, since we are dealing with mole and mass, I'm going to be focusing on that very point I mentioned. 1 mole of Na2, that's sodium triazocarbonate 4, is its molar mass. No other thing here, no volume, no Avogadro's number, no other parameters except mole and mass. So if 1 mole of sodium triazocarbonate is its molar mass, which is a fact, that will be the first line of our calculation. And I can also convert it to get a value here, that the molar mass of a compound, if I want to get it, I will have to work it out. But in this question, sodium was not given, carbon was not given, oxygen was not given. Rather, the molar mass has been calculated for you. So we are using it directly as 1 mole of sodium triazocarbonate equals to 106 gram. Now, what will be the amount in mole? That is X mole sodium triazocarbonate in 5.3 gram. That is, if you have 5.3 gram, what will be the amount in mole? Cross multiplying, we have 1 multiplied by 5.3 equals to X multiplied by 106. Dividing both sides by 106, we end up having 0.05 as our answer, because 1 multiplied by 5.3 over 106. The next question is, what is the number of oxygen atoms in 32 gram of the gas? And for you to know what to do, check the parameters given. Oxygen is 16. Avogadro's number is 6.023. It can also be 6.0 times 10 raised to power 23 mole. This is WAEC 1992. We are dealing with the element oxygen, and they are asking you that what is the number of oxygen atoms. The Avogadro's number here can be for atoms, it can be for ions, it can be for molecules. Now, we are asking that what is the number of atoms in 32 gram of a gas? If 1 mole of that gas, which is a fact, 1 mole of oxygen gas, which is O2 diatomic, contains 1 Avogadro's number. That is a fact from what I've taught you. 1 mole. Back to this table. The mole contains 1 Avogadro's number. So this is mole 2 Avogadro's number. So 1 mole of oxygen contains 1 Avogadro's number. So, but what we are having here is mass. So we need to convert this mole to mass first. 1 mole of an element, oxygen, is its molar mass. And how do we calculate that? The molar mass of oxygen. Oxygen is 16 and we have 2 of it. That is 16 multiplied by 2 gram is the molar mass of oxygen, and it contains 1 Avogadro's number, which is 32. Working it out, contains 6.023 times 10 to the power 23 ions or atoms. But in the question, we were asked that what is the number of oxygen atoms in 32 grams of a gas? So what we need to do here has been done already. The question has been answered. Assuming in the question that you were given 64, that what is the number of oxygen atoms in 64? You will write this fact first, which is the first line from the standard has been given. Then this second line will be from the question that you will write here, then cross multiply. But since this one has been given, you don't need to work it out. The question has been answered already, since you also got 32 here. But if you don't want to do it like that, you still want to prove whether we are correct or not. This line that I worked out, I got it from a well-established fact that 1 mole of oxygen gas contains one of Avogadro's number, and that 1 mole of a gas is its molar mass, which I converted to 32 because oxygen is diatomic, so that's 16 times 2. So the second line will be from the question. So if I assume this is a different number, but I can still use this. So what will be the number of oxygen atom in 32? 32 grams now from the question. Don't forget that this first line is not from the question, it's from the standard. We contain what? We can see that I can still cross multiply. 32 times x equals to 32 times 6.0 times 10 raised to the power 23. Dividing both sides by 32, x is 6.0 times 10 raised to the power 23 atoms. And that is our answer. The next question is on WAEC. It's from WAEC 1990. Question 3. The decomposition of hydrogen peroxide is represented by the equation 2 moles of hydrogen peroxide to give 2 moles of water and 1 mole of oxygen. What mass of hydrogen peroxide will be required to produce 22.4 dm³ of oxygen? So the two elements or the two compounds we are working on here are hydrogen peroxide and oxygen. That's the first thing you need to identify. Hydrogen peroxide here and oxygen. That's what we are working on. So the next thing, what parameter are we using? Mass and volume. Mass of hydrogen peroxide, then volume of oxygen. So what we need to do, if you are working with questions that has equation of reaction, you will get the established fact or the first line from the equation of reaction. Then the second line will be from the question itself. So from this equation of reaction, we can see that 2 moles of hydrogen peroxide is required by how many moles of oxygen? 1 mole of oxygen. So, but the question is asking us for mass of hydrogen peroxide. So we need to look for a way of converting moles to mass. And for oxygen, they are asking for volume of oxygen. So we'll convert this mole of oxygen to volume. So 2 moles of hydrogen peroxide in mass means that, and you know, I said that 1 mole of hydrogen of a compound or hydrogen peroxide is its molar mass. So 2 moles now will be 2 moles hydrogen peroxide is molar mass of hydrogen peroxide multiplied by 2. So we are working this out. So 1 multiplied by 2 for hydrogen plus 16 multiplied by 2. So this is like 34 times 2, which is 64 grams. So we can now say that for converting 2 moles of hydrogen peroxide gives 64 grams of hydrogen peroxide, and is required by 1 mole of oxygen, meaning that oxygen occupy a volume of 22.4 dm³, because 1 mole of a gas occupy a volume of 22.4 dm³. So from this first line that we got, which I've converted 2 moles to 64 grams, oxygen occupy 1 mole. From this equation of reaction is just 1 mole of oxygen that is produced by 2 moles of hydrogen peroxide. So here a gas occupy 1 mole of a gas occupies 22.4 dm cube. So, this is 68 because 16 times 2, 32 plus 2, 34 multiplied by 2, 68. So in this case now, what mass of hydrogen peroxide will be required to produce 22.4 of oxygen? I think we've answered the question. That's 68 grams. But if you don't want to do that, if you want to follow the normal way, you get the first line from the equation of reaction, the second line from the question. So what mass of hydrogen peroxide, S gram of hydrogen peroxide produces 24.4 dm cube. If you cross multiply, you will still get the same thing, or directly answer your question as 68. So x times 22.4, that's provided you are given a different value next time. Just follow this method. 68 times 22.4, dividing both sides by 22.4 of x. Our answer still gives us what? 68 grams. So this is the best answer. The next question, if 200 cm cube of a gas at STP has a mass of 0.268 grams, what is its molar mass? What is the molar mass of that element? Now, molar volume of a gas at STP is 22.4 dm cube, which is a standard that is known. That is, 1 mole of a gas occupies a volume of 22.4 dm cube. So 200 will occupy what? So from this question, we have volume and mass. So 200 cm cube of a gas here from this question has a mass of 0.268 grams. We want to know the molar mass. So we know that 1 mole of a gas which occupy a volume of 22.4 dm cube, you know, this is a standard. 1 mole of a gas occupies 22.4 dm cube, is its molar mass. That is, what I'm trying to say here is that 1 mole of a gas is its molar mass. So since we are working with mass and volume, 1 mole of a gas occupies 22.4 dm cube, and 1 mole of a gas is its molar mass. So I can say that 22.4 dm cube. Why did I write that first? Because volume is also here. Is the molar mass of that, is equal to the molar mass of that gas. Since we don't know the gas, so we are going to calculate the molar mass as it was asked in the question. So what we'll do here is that we need to convert this 22.4 dm cube to cm cube by multiplying by 1000. So we have 22,400 centimeter cube equals to molar mass, which is always in gram. You can see gram and gram on the same side. So rewriting this, we have 200 centimeter cube of a gas contains 0.268 gram. 22,400 centimeter cube will contain what? So we cross multiply. X times 200 equals to 22,400 multiplied by 0.268 gram. Dividing both sides by 200. Our final answer is, the final answer here will yield 30 gram. So the best answer here is D. That is, the molar mass of that gas is 30 gram. So the next question is on number 5, which is magnesium. Reaction between magnesium and hydrochloric acid to give us magnesium chloride and hydrogen. From the equation above, what mass of hydrogen would be produced if 12 grams of magnesium reacted completely with hydrochloric acid? Now, I told you that you should get the first line from the equation of reaction. So from here, identify the elements we are working on: hydrogen and magnesium. Hydrogen here and magnesium. So from this equation of reaction, what parameter are we considering? Mass and what mass of hydrogen, that's mass of hydrogen, and also mass of magnesium, because this is in gram. But we don't have this in equation in form of mass, we have it in form of mole. So from this equation, 1 mole of magnesium, which is here, nothing is here, produces 1 mole of hydrogen. So we need to convert our mole to mass. Now we know that 1 mole of an element is its molar mass, and the same is also applicable to hydrogen. 1 mole of hydrogen is its molar mass. So rewriting this first line, we have 1 mole of magnesium to be the molar mass, and the question, the molar mass is 24 for magnesium. So 24 grams of magnesium here is equal to the molar mass of hydrogen. Since hydrogen is diatomic, we need to work it out. H has been given as 1. So that is 1 multiplied by 2 grams. So that is 2 grams hydrogen, 24 grams magnesium. That is from the equation of reaction. The next question, the next part will now be from the question. What mass of hydrogen? Hydrogen is on this side. Magnesium is on this side. So 12 grams magnesium will be produced, or will be produced by what? Or we produce what mass of hydrogen? That is the question. X gram hydrogen. So cross multiplying, we have X multiplied by 24 equals to 12 multiplied by 2. Dividing both sides by 24, X will give us 1 gram. So the best option here is 1 gram. So we can see that we really need the relationship of mass and volume, mass and mole, mass and Avogadro's number. And the last question here is from WAEC 1995. What is the amount in mole of hydrogen gas that will be produced if 0.6 mole of hydrochloric acid reacted with excess zinc according to the following equation? Now here we can see that we are working with mole and mole. Mole of hydrogen gas, mole of hydrochloric acid. And in the question, we are also dealing with hydrogen and hydrochloric acid. So let's locate that in the equation of reaction which has been given. And I said that before you use an equation of reaction, ensure that the equation of reaction is balanced. And it is not in all cases that you may be working with equation of, some may require that you write it by yourself. Some may require that you don't need the equation of reaction, you just need the information given. So we are going to get the first line from the equation of reaction. The second line will be from the question. In cases where you don't have equation of reaction, you will get the first line from the parameters that is already known, as in the fact that is already known, that maybe 1 mole of a mass contains 1 Avogadro's number, 1 mole of an element is its molar mass, or 1 mole of a compound or of a gas occupy a volume of 22.4 dm cube. So from that, you can now solve your question. But in this case now, we are working with mole and mole. So 1 mole of hydrogen, in this equation of reaction, you can see that 1 mole of hydrogen is what we have here, and 2 moles of hydrochloric acid. So 2 moles of hydrochloric acid will yield, or we produce 1 mole of hydrogen. So the question now is 0.6 mole. We don't need to convert anything because we are working with mole directly. Will yield what? What is the amount in mole of hydrogen gas? That's X mole hydrogen. Cross multiplying, we have 2 multiplied by X equals to 0.6 multiplied by 1. Dividing both sides by 2, X yield 0.3 moles. And that is the question. That is the answer. So I want to commend your effort for paying attention to the end of the class, and watch out for the next class, which is on law of chemical combination, and feel free to treat more questions on this topic. Bye.